Um, all right. So in today's class, we're going to start the chapter circles. Okay. Uh, Let me just ask them to call the other students. All right. So let's first talk about what all do we know about circles, okay? So like this is a circle. And what is this point called?
The start was the center.
Center. Yes, the center of the circle. And what is this called?
Radius.
Very good. So if I say this is A, this point is A, then
Mhm.
O is the center, OA is the radius. And what about,
Diameter.
very good. So this is, let me just make it separately. Yes, so it's if I call this PQ, then PQ is the diameter. Very good. Then, okay. How about this? If I call this as RS, what is
Chord.
RS? Very good, it's a chord. And what about this portion? This, what is this?
Circumference.
No, I didn't color the entire part, right? I colored only a portion of the circle. What is that called?
Arc.
Very good. It is called an arc, right? So this is an arc. So see, if you have, let's say if you have a circle, you can, and if I mark this arc, sorry, so this part is an arc, but then the remaining part of it is also an arc, right? This is also an arc. So the small one is called the minor arc, and the big one is called what?
The major.
The major arc. Very good. Okay. Then what is this? What keeps happening? Just a minute. Okay. Now, if you talk about a chord, you said that this is a chord, then the chord divides the circle into what is this portion? What is this portion called? What is this portion called? Yeah. This is called a segment, right?
Yes. Yes.
Okay. Now, this is the minor segment, and this one is the
Major.
major segment. Very good. Now, how about you have a circle and you have the center and you have this one radius and this is another radius.
Yeah.
So this is radius and this is radius. Now, these two radii, they divide the circle into
Two
What is
halves.
this called now? Not half. Half means equal. But here we
Quarter.
can see that these are not equal. What is this called? A pizza
Quarter.
slice. It looks like a pizza slice. What is it called? It's called a
Ma'am,
sector.
oh,
It's a sector. So this is the minor sector, this is the major sector, right? A sector looks like this. It looks like a pizza slice. A segment is made due to a line segment, a chord. Okay. So that is the difference. All right. Uh, uh, uh. Just a minute. What else do you need to know for this? I think that's enough. Yeah. Okay. So now we are going to first see what is the meaning of, let's say you have a circle. hmm, this is the center, and let's say you have a chord over here. You have a chord over here, AB. Okay, chord AB, and this is the center O. And you have any random point, let's say over here, this is point C, and you connect these points AC, oops, AC and BC. Then this angle, angle ACB, is called the angle subtended by chord AB. Okay, once again, this angle over here, C, this one, this is called the angle subtended by AB. Understood what subtended means? Yes or no? Yes, Avni?
ma'am, did you say anything?
Yeah, I said, did you understand what subtended means?
Ma'am, can you give a definition one more time?
See, there isn't any particular definition as such. You can just think about it like this, that if you have a circle, okay, and you have a point over here, let's say this is point P, okay, and somewhere else, anywhere at all, you have a you have a chord, let's say QR. Hmm? And
Hmm.
then the angle subtended by QR on P or at P, this is this angle. Okay. Once again, the angle subtended by QR at P is this angle. Did you get it?
Yeah, got it.
We will use this a lot. So even if you don't understand it right now, you're going to get used to it. So you will understand it sooner or later. Okay. You will understand it. We will use it quite often in this chapter. Fine. Now, now let's do one thing. Let's, I'll just start sharing. Are you able to see my screen? The other one which I just shared.
Theorem one, right?
Yeah. No,
Yeah.
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 Are you able to see a huge circle on the page?
Yes.
No, ma'am.
Yes. Someone said no. You might have to swipe on there are many, you might have to swipe on the screen to see it, or I'll
Ma'am,
just,
I'm on laptop.
yeah, so you can see it on laptop also.
On
You
the
can
top,
just, yes, Avni?
on the top, when you're viewing someone's screen, it is there. On
Yeah.
view options, if you click the below button, the other screen.
Did you find it, Riaz?
Yes, yes, ma'am.
Hmm. Let me do one thing. I'll just fine. I think now it's going to be visible for everyone. Anyway, so this is a circle, and let me just 1 minute. Hmm. Yes, okay. Can you see this thing? Can you see this chord? Let me change its color so that I can. Huh, the blue chord, CF, sorry, EF. Can you see the blue chord, EF?
Yes, ma'am.
Hmm. Look at the angle subtended by EF. It is 36 point something. Okay, let me hide this as well. Yeah. Can you see the angle subtended by EF? It is 36 point something, 36.7 degrees, right? So, 36.7 degrees. So this is the chord EF. Okay. Now what happens if we increase the size of the chord, the length of the chord? Okay. So now look at the chord CD. The chord CD. I'll just green. Okay. The chord CD, it is bigger than the chord, it is you can say longer than the chord EF, right? Now what happens to the angle subtended by this chord? You can see it is bigger. Yeah? Are you all able to see it?
Ma'am.
So what can you say about chords, the length of chords? That when you increase the length of the chord, the angle subtended by it becomes bigger or smaller?
Good.
Bigger, right? So as you increase the length of the chord, the size of the angle subtended by it also increases. Okay. Now we are going to see. Okay. So we know that which is the biggest chord in a circle?
Diameter.
Diameter. Very good. So we said that as you keep on increasing the length of the chord, the angle subtended by it will also become bigger. So first we had the red chord, the EF. We had EF. Then we increased the size, it became CD, the green one. And then we kept on increasing and we got the biggest chord, which is GH, right? Now, what do you think will be the angle subtended by GH? Will it be, how much do you think it will be? Angle subtended by GH at B.
Angle
Yeah.
subtended. Mhm.
By the chord GH, the gray one right in the center, the diameter. Angle subtended by the diameter at B.
It will be 90, right?
Let's see how much it will be, okay? So I'm connecting these and I am going to measure the angle between them, and there you go, it is 90. And if you're not able to see it, let me hide the other angles.
Isn't this the semicircle? Because the angle of a semicircle is like.
Yeah, that is what. So that is what we're talking about. That this angle is this angle subtended, the angle subtended by a chord, which is basically the diameter, is going to be 90 degrees. This is actually one of your theorems. Understood this point, everyone?
Yes, ma'am.
Hmm. So remember, angle subtended by the diameter, no matter where you subtend it. So over here it was right opposite to the center.
Uh,
If even if it
Ma'am,
is somewhere over here. Yes, Abdur Rahman.
sorry if I disconnected. Something happened to the connection, so
Okay, fine. No problem. Just a minute. So let's take a point over here. Okay. What if we take a point over here? So as you can see clearly, this one, the GBH, the angle GBH, that is 90 degrees. But what if we take a point which is not right opposite to A, the center? Let's take a point which is somewhere else. So we have taken U. I'm going to hide all of the other line segments so that you guys don't get confused. Hmm. Okay. Okay.
So the first theorem is equal chords of a circle subtended are equal angles.
We are gonna come to that. Okay, we are coming to that. Yes. Now look at this. I am going to make that diameter. The diameter. Let me just change the color of this diameter. So I'm going to make this diameter subtend an angle on this point, on the point U. So do you think it will be 90 or what do you think it will be?
Um,
Will it still be 90?
no, it'll be a 45 or something.
Let's check, okay? It is still 90 degrees.
Ah,
Hmm. So what does this show? This shows that the diameter is always going to subtend an angle of 90 degrees no matter which point you take on the circle. Got it? Okay. Now let's come to the first theorem of yours, that equal chords subtend equal angles at the center. So over here I've already made it. What we can do is we can just hide this angle and everything. Where did the angle go? Huh. Now you can see I have tried to make three equal chords over here. So the 10, I think I should change the color of this. Wait a minute. Just a minute. Huh. So as you can see, each of the chords is 10 units, 10 units, 10 units. Can you see this? Yeah. Now we are going to see what is the angle subtended by the first, like we are going to just measure this angle, okay? We are going to just measure the angle subtended by the pink chord. It is equal to 39 degrees. And then the angle subtended by the blue chord is also 39 degrees, and then similarly the third one is also 39 degrees. So the angles subtended by equal chords at the center are equal. Okay, this we're going to do in the form of, we're going to prove it. So this is what This is the graphical representation of it. This is what we have seen in the sense that, okay, this is happening. But we need to prove that it will always happen, not just in this particular case that we are seeing, it will always happen. So for that, we will prove the theorem. So is this clear to everyone? This particular example?
Yes, ma'am.
Okay. Let me. hmm. So the first theorem says equal chords of a circle subtend equal angles at the center. Please write it down, then we will move forward. Yeah, written? Hmm. So we have a circle and we have the center of this circle. Let's call it O. Now we need to make two chords. So let's say this is one. Sorry, yeah, we need to make two chords. So let's say this is one chord and this is another chord. Same length. They both have to be of the same length. This one looks a little bigger. So okay, these are two chords of the same length. Now we are going to connect these chords. Let's say PQ and this is AB. We are going to connect them to the center so that they form. What are they forming over here? Which shape is this? Hmm?
Two triangles to
Yeah,
equilateral.
not equilateral. How do you know they are equilateral?
No, my bad. It's not equilateral.
They are isosceles, yes. Why are they isosceles? Because this is the radius of the circle. PO is the radius of the circle, right? And QO is also the radius. And then AO is also the radius. And BO is also the radius. So they are all equal to each other. Hmm? Now, so they are forming isosceles triangles. Now, can you tell me how can we show? We need to show that these two angles, excuse me, these two angles are equal. How can we show that? Just think about it. Given to you are two isosceles triangles. You need to show that these two angles are equal.
Can we use any rules?
Yeah, of
Like,
course.
then we can use.
You've studied triangles chapter. We've studied that chapter for so long.
Ma'am, we can use SSS rule, right?
Okay, we can use SSS rule. All right. So what is given to us? Let's first write what all is given. Okay. PO is equal to, given is this thing. This thing is given. And then PQ is equal to AB. This is also given that they are equal chords. Equal chords of a circle. So now the solution or the proof in triangle. Yes. Who will tell me? In triangle this and triangle this.
Triangle AOB
Hmm.
and triangle
And
POQ.
Very good. And triangle POQ. What all do we have? PO is equal to AO, radii of the same circle. Of the
OQ is equal
same
to
circle.
OP.
OQ is equal to OB, again same reason. And then PQ is equal to
PQ,
AB.
i-
Why?
it's given.
They are equal chords. Yes. So they are equal chords. That's why PQ is equal to AB, and it's given also. So therefore, by which rule?
SSS.
SSS rule, these two triangles are congruent. Triangle POQ is congruent to triangle AOB, and therefore, by
CPCT.
what is equal to what?
Angle POQ is congruent
Hmm.
to triangle AOB.
Angle POQ is equal to angle AOB. And that is something we just saw um, in the graph. Okay. So I have shared it once again. If you guys want to take a look, I have shared the screen. All right.
We should note it down, right?
The theorem, yes. Acha, wait. My screen has not started, the other screen has not started sharing it. Note it down and then we will just take a look at the figure once again. Done?
Ma'am, 1 minute.
Okay. Now we will do the converse of this theorem, okay? If two chords subtend equal angles at the center of the circle, then the chords are equal. Yeah. How will we do this? First of all, we are going to make the diagram. We are given that there are two chords, not necessarily equal. It's not given to us that they are equal. I'm gonna make it over here. We have been told that they subtend equal angles. So we have been told that there are two chords. We don't know whether they are equal or not yet. We have been told that they subtend equal angles at the center. So it is given that this is equal to this. This is given to us. So what else is given? Let's write it. So let's call this
We should write
A.
this question.
Yes. Why else am I doing it?
Okay.
A, B, C, D. Okay. So given is that, first of all, AO is equal to BO is equal to CO is equal to DO is equal to radius of the circle. Hmm? Then it is given to us that angle AOB is equal to angle COD. This is given. See, two chords subtend equal angles. We have to show that the chords themselves are equal. AB is equal to CD. How will we do this? Anyone? Yes, Abdul Jabbar, you want to give it a try? Who wants to give it a try? Avni, you want to go?
I have no idea.
Arey, come on, look at it. It's given. CO, DO, AO, BO are all equal. Then there is an angle in between them. You've studied this in triangles chapter. Only the circle was not there in the triangles chapter. Come on, this is very easy, guys. Abdul Jabbar, unmute, please.
Yes, ma'am.
Huh. First, tell me in triangle what and what. Which are the two triangles you see in front of you? Abdul Jabbar, yes. Name the two triangles, bache.
AOB and
And
COD.
COD. What's taking you guys so long? Huh? In
It's
triangle this and triangle this. Then, is there anything equal that you can see from the figure?
ma'am, AO equal to DO.
DO also you can say, and you can say CO also. Okay. Then
BO equal to CO.
BO is equal to DO. And what else?
And angle AOB equal to angle COD.
Very good. This is given. So these two are because radii of the same circle. This is the reason. And this is because it is given in the question that they are equal angles. So therefore, now can you tell me which rule is being used?
SAS congruency.
Very good. By SAS rule, triangle AOB is congruent to triangle COD.
By CPCT CD
Very
equal to
good. AB is equal to CD. Very good. Yes. Avni, understood?
Yes, ma'am, understood.
Good. So please note this down. Done?
Ma'am, 1 minute.
Done? Okay. Just a minute. I think I have not written the date here. Okay, the next theorem. Just a minute. I will show it to you in the graph itself. Hmm. Okay. Hmm. Hmm. Yes. So here we have a circle and there is a chord. Okay. The the theorem is saying a perpendicular. Okay, if you drop a perpendicular on this chord, so perpendicular from the center to the chord bisects the chord. What does that mean? That if you drop a perpendicular, this one. It's still not visible. Wait. Huh. Hmm. So can you see this perpendicular? So we already have a chord, the red one. We have a chord and we are dropping a perpendicular on that chord from the center. So from the center, we have a perpendicular on that chord. The chord's length is written over here. It is 20 units. The question is, the theorem says that this perpendicular is going to bisect that chord. What is the meaning of bisect that chord? Bisect. What's the meaning of bisect?
Bisect means, ma'am, it passes through another line.
Okay, if I say I am bisecting this pen into whatever, I am bisecting this pen, what does that mean?
Dividing into two equal
Into
parts.
two equal halves, yes. So when we are saying that the perpendicular, meaning the blue line, bisects the chord, that means the blue line is cutting the chord into two equal halves. Yeah, and we can even verify that for ourselves. See the distance between S and T, the this it they have measured it and it's showing us 10. Okay, the distance between S and T, ST, the distance ST is 10 and the distance TW is also 10. So the original length, the chord's length was 20 and it is being bisected. So both of them are equal. The both of the parts of this chord that they are divided into are now equal. Understood what this means? Perpendicular to a chord bisects the chord. Did you understand this? Yes or no?
Yes, ma'am, understood.
Understood. Abdul Jabbar?
Yes, ma'am.
Understood?
Yes, ma'am.
Okay. So just remember this, perpendicular to a chord bisects the chord. Okay. I'm going to share the whiteboard again. So perpendicular to the chord bisects the chord. So we're going to prove this. I am going to draw a perpendicular over here. Sorry, a chord over here. And we are going to drop a perpendicular on it. So this theorem, it says that the perpendicular is not going to be like, falling over here or anything. If it is a perpendicular from the center, it will always be bisecting it into two equal halves. So this is your center, this is your chord, and doesn't matter where you draw the chord. If there is a perpendicular from the center to that chord will always be bisected by it. So let's call it AB. Okay. Done till here? Now what we are going to do is we are going to just join OA and OB. So now can you see there are two triangles being formed? Can someone tell me? Acha, first of all, we need to show that this is being bisected. Meaning, what do we need to show? Look at the question and tell me. We need to show that the chord is being bisected. Meaning, what do we need to show? Something is equal to something. What is that something?
Oh, no.
The chord is being bisected. So what do we need to show?
We need to show that if OA and OB is equal.
But say O and OB are obviously equal because they are both radii of the same circle, hai na? So they are going to be equal. If this is R, the radius of the circle, then this is also R only because it's the radius of the same circle. So they are, sorry, they are already equal. What do we need to show? Look at the theorem. See, let me show you, let me tell you how this theorem came into being, okay? In the sense that how can we interpret this theorem? You have a chord. You have a chord. And the question arises, what will happen if you draw a perpendicular on this chord from the center of the circle? The answer is that chord, the blue one, will be divided into two equal halves due to that perpendicular line. So that is what we are trying to show in this theorem, that this is actually true. This isn't just some made up story, it is true. And it is always going to be true no matter where you draw the chord and how long it is, how short it is. Doesn't matter, it's always going to be bisected into two by the perpendicular from the center. Okay, now tell me, to show that, you have to show that bisects the chord, meaning what is, like, numerically, what do you need to show? I gave you a hint, something is equal to something.
AM is equal to.
Radius is equal to.
Very good. AM is equal to BM. Okay, this is what we need to show. What all is given? It is given that OA is equal to OB. Why?
Because radii is equal.
Radii, very good.
And
One more thing
OM
is given.
common. OM common.
Achha, that is in the solution, okay. But look at the pink thing that I have highlighted. What is given? Perpendicular from center to chord. What does that mean?
Angle. Wait.
What angle? Which angle?
Angle OMA
OMA.
is equal to angle BMO.
And that's it. Abdul Jabbar, what will be the measure of this angle?
9.
Good, Avni. It will be 90 degrees because it is perpendicular na. Perpendicular means 90 degrees. So now solution in these two triangles, in triangle OAM and triangle OBM. Please write it. OA is equal to OB radii. You can say OM is equal to OM. Why? Because common. And then angle OMB, OMA, sorry, is equal to angle OMB because it is 90 degrees given. Now, which rule are we going to use here?
SAS.
SAS. This is S, this is A, this is the other S. In SAS, we discussed this that the angle is supposed to be included between those two sides. The angle that you're talking about is supposed to be between the angle that is sandwiched by those two sides. But over here, the angle is not the angle between these two sides. The angle between these two sides, the angle between these two sides is this angle. But this is not the one we are talking about. Abdul Jabbar, any ideas? Ever heard of RHS? What happens in RHS?
Right angle
Right
hypotenuse.
angle. So we have a right angle over here, right? OMA and OMB. Hypotenuse. Hypotenuse means this one. OA and OB are the hypotenuse. And side. Which side have we taken? We have taken OM is equal to OM common. So this is RHS. Therefore, triangle OAM. Please write this quickly now. By RHS. Therefore, AM is equal to BM by CPCT.
Ma'am, in the given, the second line is OMB, right?
Where, bache? Acha, this one. Yes,
Yeah.
angle OMA is equal to angle OMB.
Okay.
Done?
Mm,
Done? Now, conversely, this is the converse part of the theorem. This is the converse of the theorem.
Is converse.
What is converse? Converse means if I say if A is true, then B is true. Okay. The converse of this is if B is true, then A is true. For example, in the previous question, the first theorem that we did was equal chords of a circle subtend equal angles at the center, meaning that it was given to us that these two chords are equal. PQ and AB, it was given to us that these two are equal. And we had to show that this angle, these two angles are equal. Okay. So the converse of this theorem is that if equal angles are subtended at the center, then the chords are equal. Okay. Which is what we did in the next question, which was if two chords subtend equal angles at the center, then the chords are equal. Understood the meaning of converse?
Yes, ma'am, understood.
Sorry. So the converse of this theorem is, and we're going to do it quickly because we don't have much time left for today's class. So this theorem said perpendicular from center to chord bisects the chord. So what was given? Given was perpendicular, and to show was the fact that they are bisected. Now over here we're going to have opposite. We're going to have given that the chord is being bisected, meaning given that AM is equal to BM. Let's first make or what I'm going to do is I'm just going to copy paste this thing. You all please make a new figure, okay? Quickly. Doesn't have to be very neat. It's going to be the same as the previous figure, okay? Given AM is equal to BM, and over here we have to show that angle, or we can say to show that OM is perpendicular to AB. So the theorem statement is going to be the perpendicular, or not perpendicular, the line from center, or one sec. Okay. The line from the center which bisects the chord. You can say the bisector of the chord also, okay? The line from the center which bisects a chord is perpendicular to the chord. So to show that is that it is perpendicular. That's what we have to show. And it's given that it bisects the chord. The bisecting wala part is already given. We have to show the perpendicular wala part. So it's given that AM is equal to BM. Now again in triangle O or AOM and triangle BOM. OA is equal to OB again, radii, and AM is equal to BM because it's given in the question. And what else do we have? OM is equal to OM common. Now which rule have we used here?
Yes.
Good, SSS. So therefore angle OMA is equal to angle OMB by CPCT, but we are not done yet. So let's say it is equal to X, okay? So that means X plus X is equal to 180 degrees, linear pair. See, this is our X and this is also our X only. We have just proven that they are both equal. So that is why we are calling both of them as X. Now, obviously, they're going to be equal to 180 degrees because it forms a linear pair. There are two angles on the same line. So if there are two angles like this, X and Y, on the same line, we say that x plus y is 180 because they are a linear pair. So here both of them are x. So x plus x is 180. That means 2x is 180. That means x is 180 by 2, which is 90 degrees. So that means angle OMA is equal to 90 degrees. That means OM is perpendicular to AB, hence proved. Okay. Please note it down, and once you're done, you may leave. If there are any doubts, however, you may ask. Sorry.